So in this case, we are simply going to consider our introduction to the differential calculus, which is important as you are going to be considering your derivatives for your mathematics N4. So this is due to the request, guys, from our membership. So it is important that we consider these introductions for our mathematics that is working with the differential calculus and also the integration. So like I said, it is a request which is from the membership. So it is going to be important for you to consider all the classes. So you just have to try to join membership so that you won't miss any of the other classes. But if you consider other videos that I've done previously, you will see that we have enough information that can actually make you pass these exams. So the membership platform, we just have to acknowledge it, guys, as we are having this. We also need to uh just has to work hand in hand. I just hope you understand. So we'll see as we are having our revisions, but as per our introduction, what is important in your derivatives, guys? It's not that much. You need to consider the limits. There's another video that I did. It's a long video. There is a lot that I explained there. So you can actually go through that video. I have everything there, but we shall just consider each part separately. So on the introduction, we need to know the limits. You also gonna consider the binomial theorem. These are some of the things that you actually going to need as you are working with what as you are working with the differential calculus. Then the use of the first principles. All right. So, like I said, we're gonna have separate classes of these. Then the differentiating of the function, meaning to say, considering the standard functions, which is going to lead us to the rules of our derivatives and also the applications of the second order of our derivatives and the application of our derivatives. So there is actually, it's not that much. Yeah, we just need to go through your syllabus according to the textbook that you're having. Like I said, make sure that you are working with the revised curriculum. So in our case, we are going to be considering the limits. That will be our introduction for this class, working with our derivatives. It is also important that we do understand the limits. What is it that we are considering as we are working with the limits? So a limit is simply a value that a function or a sequence approaches. If you're given a certain function, let's say 5x plus 3. So it is the value that it is going to be approached by this function as the input tends towards a certain value, as the input tends towards a certain value. So the input is the value that you're going to be substituting, like it is tending to say, you're saying x is approaching 2. So this is like this, x approaches 2. So x approaches 2. So it's not like it is to that it is that value, like it is going to be at that value. The value of x is approaching to a certain, like let's say x is approaching 0. There are values that you'll be given. Let's say you are doing calculations, then you've got something like 0,0000, like they like this, guys. This value that we are seeing, it is actually approximating to 0. It is approaching 0. So as we have the values of our limits, we are going to be using a certain value that we are substituting into the function. All right. So as x is given to a certain value, it simply means we are supposed to substitute that value. That is the limit to that function, the limit to a function. So if I'm given, let's say I'm just going to consider something like this, the limit of x as x is approaching 2, then you have a function here. You'll be given a certain function of x, which represents the part of x. So let's say we are given 2x squared plus 3. What does it mean? It simply means in place of x, substitute the 2 that we are given. So this whole part that we are seeing here, we are simply going to have 2 into, in place of x, that's 2 plus 3. All right, that's a squared there, here. So take note, in place of what? In place of x, you substituted the 2 here. In place of x. So you can simplify this, right? So, all right, let me just have my calculator to the normal mode. All right, let's do this. So this is 2 into what? Into 2 to the exponent of 2 plus what? Plus 3. So this is the idea of the limit to a certain value. This is the idea. You are substituting that value into x, in place of x. So you'll be given certain values, certain functions as you consider your limits, and also you're supposed to note as you are working with the limits, there are some terms which are not exactly known or they're actually undefined. Okay, let's bring our calculator here. There are numbers that we cannot simplify. Let's say we've got 0 divided by 0 like this. Are we seeing what is happening? We cannot simplify this. It is undefined, cannot be simplified. So these conditions, actually, they are indeterminate values. So we have got this part of indeterminate. Which condition is it that we're talking about here? Not exactly known. We do not know that. The calculator cannot even simplify that. So these are the conditions where we've got 0 over 0, maybe infinity over the infinity like this. So when you are given these conditions, there are ways that you're supposed to simplify. So we're going to talk about that in detail later on. But before we consider that, I just want you to know some of the properties that you need as you are working with the limits, some of the properties of limits. The properties of limits. As you are given a certain value, a certain limit, there are some properties that you need to know by head, by just being given. You need to know, okay, this one is going to approximate to, is going to give me a certain value like this. These are the ones that we need to list. All right, so we've got the limit as x is approximating to, as x is given up to infinity, and we've got 1 over x like this. So in this condition, in place of x, we are going to substitute infinity, and it follows that 1 over an infinity like this is equivalent to 0. 1 over infinity is equal to 0. So in actual sense, if you're given a constant over infinity like this, still it's going to give us what? A 0. So that is a condition that we are having here. In place of x, we are going to substitute the infinite. So that is going to give us what? A 0. So it is the opposite now. If it is now the limit as x is approaching to what? To 0. In place of x there, we are now substituting what? We are now substituting what? We are now substituting in place of x. So what is going to be the condition is just the opposite of what we are having here. When it was 1 over infinite, we got a 0. So when it is 1 over 0, this one is going to give us what? It's going to give us infinite. So that is the condition. 1 over 0 is equal to what? Infinite. Meaning to say a constant over a 0 like this is going to also give us what? An infinite. So these are the conditions that you just need to understand as you are working with your limits. And also as you consider a constant, let's say we have got a constant. The limit is for x, all right? As x is approximating to a certain value, but we are given, in this case, a constant. Guys, this constant, we do not have x there. The limit is supposed to be substituted where we see x. The limit of x is approaching to a certain value. It is approaching a certain value there. A certain value, which is 2. X, we are talking about x there. So it must be f of x. It must be a function of x that we are seeing here. Not to say we are given a constant like this, x is approach to 2. Then we are given a number which is 3 like this. We cannot substitute a 2 in place of 3. It's impossible. It's a constant. So in that case, we are simply going to obtain the constant as it is. You cannot simplify that one. So as x is approaching to a, we cannot substitute a in place of x, a k, where we are supposed to be having what? X. We are supposed to be having a function of x there. So if we do not have that function, that means it is going to remain as it is. What I'm trying to say, guys, is that, okay, let me write this way. The limit of x is approaching to a like this. Then it is f of x. We can understand it that way. It means it was f of x. So in place of x, we're going to substitute. If it is 2, I'm going to substitute a 2. What about if it is a? In place of x, I'm going to substitute a. So let's say we're given something like this, 2x plus 3. Then you substitute a here in place of x. How are you going to have it? It's going to be like this, 2 in place of x, you substitute a like this, plus 3. Guys, what has changed? It was before written in terms of x, and you were saying it is f of x. Now it is written in terms of a. So what does it mean? It means this is our f of a. So substituting a in place of our x there, it means what you're going to be having in actual sense is what? Is f of a. That is what it means. Substituting a in place of what? In place of x. So this is the consideration that you have on your limits. So these are some of the properties that you're going to need to put into consideration. And also, as you are having these limits, you are also supposed to put into consideration. All right, let us consider, let's say there's a constant which is multiplying a limit. We are given a limit as x is approximating or is approaching to what? To a, and that is k f of x. This is a function of x. There's a constant. There's a number that is multiplying the function later on. Remember, a constant is not affected. So your constant is going to be on your final answer as it is. But when we substitute this into f of x, we got what? We got f of a. So it's going to be k f of a. That is our consideration there. And another part, we can have this on the separation, a sum or a difference. Let's say we are given addition and subtraction of our limits. Okay, so you can have that condition again of a sum and a difference, whereby we have got two functions that are being considered. Let's say we have got f of x being added or subtracted to gx. Okay, like we are adding gx or we are subtracting gx from what? From f of x, like this. We can simplify this. In which manner? These are separate. We take them as separate, meaning to say when I have limit to f of x, then limit to what? To gx. So it's going to be like this, limit to the f of x, So x is x approaches to what? To a here. Then we have got f of x, the same, plus or minus. Sign that you're given there as it is. Then we've got our limit again as our x is approaching to what? To a, and this is g of x. So this is what we have in this consideration. Remember what we had before. If it is a limit as x is approaching to a, we're going to substitute a in place of what? X, and it gave us f of a. So in this manner, what does it mean? If I am to substitute a in place of f of x there, where x is, I'm going to have what? F of a at the end. The same thing here in what? In our gx. If I'm to substitute x there, it will give us what? Ga. So that is what it means at the end. So it simply means separate your limits. If you are given sum and difference like that, you can separate them. This is all about our limits, guys. Simplification, guys, those simplifications, they are supposed to be taken into consideration. And also if you are dealing with the infinite there, as we had there, that 1 over infinite will give us a 0. The infinite on its own, it has some properties that we can consider. If you take an infinite like this, you raise it to a certain exponent, it means we are simply going to have what? An infinite. Raised to a certain exponent, we're going to have what? Infinite. Provided that we are having what? A positive there. Let's say positive n. N is positive. If it is a negative, it's going to be like this, 1 over. So it will be like this, 1 over what? Infinite to the exponent of n. If it is a negative, like let's say we are given an infinite to the exponent of a negative, it will be written like this. And remember, infinite to the exponent of a positive gives us that it remains as infinite. So it will be like this, 1 over what? 1 over infinite. And 1 over infinite is what? Is 0. Remember that concept that we had here, 1 over infinite on this part when x is approximating what? To infinite. It's going to be a 0. So it means when you see 1 over infinity, you're going to have what? A 0 at the end. So take note, a negative there. A negative exponent is going to be 1 over. But the concept is not changing to say an infinity raised to a certain exponent, which is positive, remains as infinite. An infinity when raised to the exponent of 2, guys, when it will remain like that, does not change. To remain as what? Infinite. So you must be careful. And also it applies the same thing if it is a certain number, let's say a to the exponent of an infinite. It also gives us the same concept. When it is positive, it is going to give us what? Infinite. When raised to a positive infinite. What about when raised to a negative infinite? It's going to be, how do you remove this? 1 over a to the exponent of infinite, where it gives us what? Infinite. So it's going to be 1 over infinite, which is going to give us what? A 0. So you see these considerations. They are also part of your simplifications that you just need to put into consideration. So I want you to have that in mind as you are to simplify your limits later on. And okay, it's going to be important as you are having your questions. So the procedure, you just have to consider as you are simplifying, you substitute the value of a that you are given, simplify where it is applicable. All right. So in terms of the simplification, all right, let us just have here 1 or 2 things. So the procedure on simplification. So this is what you're going to need. You substitute like for a limit. And for a limit, let's say we are given to find the limit of x, which is approaching to a of f of x like this. So the first thing that you're going to need is just substitute. You substitute the value of a All right, so substitute a in the function. You substitute a in the function, then apply the properties of what? Limits where it is applicable. All right. Apply properties of limits where applicable. So that is what you're going to need. And meaning to say, sometimes we might not get what we need from the simplification. Like you substitute, then you find out that we are obtaining those terms that are not, that you cannot simplify mathematically. Remember our indeterminate form. We cannot simplify that part. So meaning to say, it can be a consideration of that nature. You simplify, you substitute, then you obtain this consideration. That means our properties of limits are not applicable in that manner. So what are we going to do? We try factorization to simplify our terms. So where applicable, again, so this is another part where applicable, try factorization. So as we can see, it's a matter of trying. You're going to try factorization. Some of the terms after being factorized can cancel, then you substitute your limits, you see. So that is the idea there. If factorization is not applicable, the last part that we're going to have, it will be for the limits, for these limits whereby x is approaching to infinite. Only for this condition. If this condition is there, and if any of these are not applicable, the properties of limits, the factorization is not applicable again. Where we have an infinite, we are going to divide each term of the numerator and the denominator by the highest power of x. Only for this condition. The other part that we are supposed to use is actually for N5. So we're not going to talk about that. We're talking about in our N4. These are the three things that you have to consider. So if one of these two fails, then it means we must consider, okay, do we have an infinite there? X is approaching to what? To infinite. All right. It is that consideration. Then you try, or you definitely, in this case, you have to divide. All right. So our condition, when it is like that, you are going to divide each term. Divide each term of the numerator. Divide each term of the numerator and the denominator. All right, both of them you must consider both. All right, the numerator and what? Denominator. So we are going to divide them by what? By the highest power of x. By the highest power of what? Of x. So this is the condition that you're going to have. So you divide, you substitute what? The limit that you're given, just like what we said there before. All right. So after that, you are going to what? Substitute. And just like our condition, you substitute the limit and simplify. Using what? The properties of limits. Now simplification is applicable. The properties of limits, they will be applicable once you apply this condition. Remembering this part that I was talking about when we have the limit when it is raised to what? To a positive exponent. It's going to remain as what? As infinite. It's going to remain as what? As infinite. 1 over infinite, what? It's a 0. So it simply means even if it is a constant over infinity is going to be also a 0. All these are supposed to be put into consideration. And also, in your simplification, as you are considering this procedure that we are having here, it is also important for you to consider application, because as you can see here, guys, we talk of the factorization, this and that. So sometimes it is also important if you're dealing with trig functions, for trigonometric functions. All right, for trigonometric functions, it is always best that you apply identities where applicable. Apply identities, our trigonometric identities where applicable. All right. And for other factorizations that are important, remember your difference of two squares. The difference of two squares. Remember also that it's going to be important in your simplification. Remember our a squared minus b squared, which is equal to what? A minus b into a plus b concept. Our difference of two squares. Also, it's going to be important in your simplification to know or to understand the sum and difference of two cubes. Sum and difference. Sum and difference of what? Two cubes. Remember also this, because it's part of the factorization. So remember, for the sum, we've got x cubed plus a cubed like this, which will give us what? X plus a. If it is like this, it's going to give us x plus a into x squared minus ax plus a squared. So x is the first term, a is the last term. All right. If it is for the difference of two cubes, where we've got x cubed minus a cubed, this can be factorized using x minus a. Then this bracket will be adding x squared plus ax plus a squared like this. All right, so that is the condition that we also going to need in our application as we are having our limits. All right, so that is the condition, guys, just simple like that. So like I said, we just need more revisions there, and that can help. So yeah, guys, let's see. Let's see just one or two questions that you're gonna consider. Then we'll see more revisions. Like I said, guys, you're gonna need to join membership. There's no way. As you can see, guys, there's a lot. There's a lot, as you can see. All right, let's say we are given to simplify or to determine one of these limits. We are given the limit as x is approaching to 1, and this is given as 3x plus 2 over 5x. So this is the case, guys. Just substitute, all right? The given values that you are given, the given expression, x is what? 1. So in place of x, it means you must substitute the 1 in place of x, where you see the x. So that is our consideration in this case. So it's going to be 3 into 1 plus 2 over 5 into 1 like this in place of x. So that's it. You can simplify this 3 plus 2, which is 5 over 5. And 5 over 5 is what? Is 1. We can simplify that. It's direct. All right. It's something which is direct. You're just substituting the value that you're given of what? Of the limit there. You're just substituting. All right. So if I'm given the limit of x, which is approaching to 0 as it is, then we are given this as 13x minus 5. What does it mean? In place of x, substitute a 0. That is what it means. In where you see x, put a 0 there. So that's 13 into a 0 minus a 5. So that will be 0 minus 5, which is what? Minus 5. That is the condition of what? Your limits. Just like that. So if we are given limits, guys, substitute as it is now into some of the terms because of these trigonometric terms. Let's say we are given a consideration where we are given the limit as x is approaching to pi over 2 like this. And we are given 5 sine x. This is what we have. X is approaching pi over 2. So what does it mean, guys? Remember the radian conversion, the radians and what? And degrees concept. Radians and degrees. What is the relationship? For pi radians, we've got what? 180 degrees. Or you can use 2 pi radians equal to what? 360 degrees. Any of this. It's up to you. So if you're using pi, it's up to you. You can use this. So meaning to say, wherever I see this pi, I can substitute 180. So it will be 180 over 2, which is what? 90 degrees. If you want to simplify as it is like this with the pi, it means your calculator must be in, right? If I simplify 5 sine in place of x, I put this pi over 2 as it is like this. My calculator automatically must be in what? In radians. This is pi. They are radians. These are values in radians. As long you do not see this degree, this one, it means that value is in radians. A decimal or what that will be given, that value is in radians. As long you do not see the degree, your calculator must be in radians. So you can change your calculator, shift, go to the setup, then radians on number 4. Your calculator is now in radians. You got the R there. So we're going to substitute 5 sine of what? Pi over 2. That's shift to put our pi here over what? Over 2. Just like this. We can simplify this. That was going to give us what? A 5. So this is going to give us a 5. All right. So that is the idea. But if I'm to convert to the degrees now, like I said, this was going to give us what? 90 degrees. So therefore, we're going to simplify it this way, this limit. It was going to be 5 sine of what? 90 degrees, meaning our calculator is supposed to be back to that normal mode in the degrees, not radian. We are supposed to go back, shift, go back to the setup, to the degrees, number 3. You're supposed to be writing a D there. You're supposed to have a D here on top. It's supposed to give you a D, degrees. So this time we're going to evaluate as it is 5 sine of what? 90 degrees. As we can see, our answer is the same. So it is up to you. Are you going to change your calculator to the radians, or you are going to change the radians on the question to the degrees so that you maintain what you have on your calculator? This is the idea of the limits. When you're given the trigonometric functions, degrees, you must see this degree, this one. If you do not see it, it means that value is in radians. Any condition that you have, any that you see, as long you do not see that degree, whether it's a decimal, whether it's what. So you convert using that conversion. Pi is equal to 180, or use the 2 pi. It's up to you guys which one you're gonna have. So that is it. So like I said, some of the parts you're gonna need, the factorization. So this one, let me write it here because this is where I applied my identities, or the sum and difference of the 2 cubes, this and that. So you can be given a limit. Let us have this as our last question. And like I said, guys, be part of the membership so that you won't be limited to any of the classes, or even for you to ask other questions that you feel like, okay, this one is having a challenge. Maybe you've got an activity that is having a challenge. Joining membership will be the best way so that you won't be limited. Guys, for N4, I think it's like 40 rand. Is it? 39. 39. It's like something for airtime that you do, like your airtime for the month, and not even for month, for one, for a day. For a day, it's actually airtime for a day. So if you're considering, guys, I think that would be best that you just join. There's no way, just join, okay? Just join, guys. Just join. All right, so this is it. We talked of the factorization. There's another part that is still missing. No problem. Let's talk about this one. We can factorize. If we were to, okay, like here, the 3, I see like there's a fact that is missing here. All right, the 3 here, as x is approaching to 3. All right, so in this case, we are going to substitute. I wanted you to see what was going to happen. We are going to put 3 there on top. So it was going to be like this, 2 into 3 minus 6 over. Here it was going to be what? 3 cubed minus 27. 6 minus 6, that's a 0. 27 minus 27, that's a 0. All right, this was going to give us 27 minus 27. As you can see, this cannot be simplified in determinate form. So what are we going to do? On our procedure, we said, if this is happening, we are going to try factorization. So let's apply factorization. The numerator, can it be factorized? So we can factorize this one. So it's going to be limit as x is approaching to what? To 3. Then we factorize the numerator. 2 terms. 2 is common there. We can simply factor out the 2. So factoring out 2, 2x divided by 2, that will be x minus 6 divided by 2, that is minus 3. Remember, guys, your factorization basics of what? Your N3. Now here on the x cubed minus 27, which type of an expression is this? If you consider properly, we are back to the difference of 2 cubes. X cubed minus 27. Why am I saying it's a difference of 2 cubed? 27, this one. It's a perfect cube. You can test this one on your calculator for the sake of time. You write this way. 27 is equal to, then shift fact, like this. 27 is equal to, then shift fact. It gives us 3 to the exponent of 3. So it can tell us that 27 that we see here is same as what? 3 to the exponent of 3. So it's just like we've got 3, x to the exponent of 3 minus 3 to the exponent, like this. So this tells us that we have what? Difference of 2 cubes, where we've got our a and b, the first and last term. This is our first term. This is our last term. So according to our factorization, when we have got the first term and the last term in this manner, how are you going to factorize? It is telling us that our factorization is going to give us what? First minus last in the first bracket. So it was going to be first minus last, x minus 3. First term minus last term. After that, what are you going to have in this bracket? X squared, which is the first term, x squared. Our first is what? X. So it's going to be x squared plus ax, the product of a and x, the product of these two. The product of these two. So x times 3, or 3 times x is what? Is 3x. Plus a squared, the last term, our a, being squared. So our last term here is what? Is 3. Being squared. 3 squared is what? It's 9. Like this. We have factorized. That is what it means. Know the factorization of these types of expressions. X cubed plus 8. Sum of 2 cubes. These types. Know how to factorize these. Go through your factorizations like that. All right. Sorry, I'm erasing my answer there. So this is what you're going to have. You factorize what? That x cubed minus 27. This one. So it's going to give us this. So we've got 2 brackets here. X minus 3 into what? X squared plus 3x plus 9. As we can see, guys, here, very true that we have a quadratic expression inside of the bracket. Exactly as what we can see here. It means this part cannot be simplified. Never waste your time to try to simplify this. It cannot be simplified. If it was to be simple, they could have indicated here that this can be simplified. But giving us like this, it means it is done here. So this bracket, this one, never waste your time here trying to factorize this. You won't have any factors there. So remember, like I said, factorize and what? Simplify further. Which simplification that need to be done here? As we can see, x minus 3 are the same. They can cancel each other. So we were going to have this. Let me just rewrite our question. We are now having limit as x is approaching to what? To 3. Then we have got 2 over what? So this is 2 over the whole part of x squared plus 3x plus 9 like this, all right? So this is what we have. So in this part, we're going to substitute now, just like what we had. This is in simplest form, so we're going to substitute direct. So it was going to be 2 over what? In place of x, we put what? 3, where we see x. So here is 3, that's 3 squared, plus 3 times what? 3 times 3 plus 9, just like that. Just like that. So this can be simplified. So it was going to give us 2 over what? 3 squared. Or you can even use your calculator there. But 3 squared, that's 9, guys. So it's just going to be 9 plus 9 plus 9, isn't it? 9 plus 3 times 3, which is 9 plus 9. This is 18. 9, 18, 27. So it's 2 over 27, just like that. So this is the part of our limits. This is the part of our limits, how they can be like. So like I said, guys, do as many questions as you can. Do as many questions as you can. So sometimes you might be given a condition, like I was saying, where all these are not even applicable. All these are not even applicable. Let us consider this. I wanted that one to be our last question, but I say that we still have just 1 or 2. All right, this one, let us just finish with this one. The limit of 18, let's say, okay, x is approaching to infinity like this. Then we've got 18x cubed minus 17x squared plus 2x minus 9 like this, whatever that you're given. This is 3x cubed minus 2x squared plus 3x minus 7 like this, guys. As we can see, there is an infinite. Remember, it's only that all right, I do not know now. Where did I put that? But no problem. Let's open here. Okay, it's this one. On these procedures that we had, we can have the substance of A, which is the basic of your properties, where applicable, try factorization. And when that is not even applicable, but for this limit where x approaches to infinity, divide each term by the numerator, each term of the numerator and the denominator by the power of x. By the highest, here supposed to be by the highest power of x, the highest power. The highest power of what? Of x. We have infinity here. We have infinity. So looking into, guys, look at this. Even that cubic expression, for you to be factorizing this is going to even take you a lot of time. So simply apply that concept. In terms of this part, which part has got the highest power? The highest power, the highest exponent of what? Of x. So you see x to the exponent of 3. Same exponent, 3. So we're going to divide each and every term like this. Each and every, you are supposed to divide each and every term by that term, this by that x here, by x. The part is supposed to be x. The part that we need is what? Of x to the exponent of 3. This x to the exponent of 3. So it's going to be like this. 18 x to the exponent of 3 over that 3. This x to the exponent of what? 3. So it's x to the exponent of 3. Minus, you move on, 17x to the exponent of 2 over x cubed. Each and every term. 2x over what? X cubed. Minus 9 over x cubed, like that. So this is what you have in the numerator. Over what? The denominator, the same thing. 3x to the exponent of 3 over x cubed. Guys, this is what you're going to have. Minus, you do the same thing, 2x to the exponent of what? Of 2 over x cubed. The same thing here, plus 3x over what? Over x cubed. Minus 7 over x cubed. The highest exponent in x cubed. So let's simplify and see what you're going to have in this case. Let's simplify and see. So as we can see, this was going to cancel. We have got 18 minus x squared into x cubed is going to be x. Remember, there are 2 of them. Here there are 3. So we're going to have 1 in the denominator. So that's 17 over x. Here, that is 1. Here there are 3. So we're going to have 2 of them remaining. So that's 2 over x squared. Here there's nothing to cancel. Negative 9 over what? X cubed. Everything like this. We do the same thing. This one and this one are going to cancel. So that's 3 minus the same thing. There are 2. Here there are 3. So we're going to remain with 1. And that's 2 over x. This one is 1. Here there are 3. So we're going to remain with the 2. So that's plus 3 over what? X squared minus 7 over x cubed, like this. So this is what you're going to have from the numerator, and here from what? The denominator. So if we are to substitute now our limit, in place of x, you substitute that infinite. It means we're going to have 18 like this, minus, this was going to be 17 over what? Infinite, like this, plus 2 over what? Infinity squared, minus 9 over what? Infinity to the exponent of 3. Everything over the same thing. The same thing in the denominator. This one was going to be 3 minus, in place of x, 2 over what? Infinity, plus, in place of x, 3 over what? Infinity cubed, minus 7 over what? Infinity to the exponent of 3. But remember what I explained about this infinity when being raised to a certain exponent being positive, it remains as what? As infinite. But 1 over infinity is what? It's a 0. 1 over infinity, it's a 0. So it simply means 1 over infinity to a positive there. 1 over this one. 1 over infinity. 1 over infinity to a positive exponent. This part will give us what? Will give us a 0 at the end. And this is exactly what we are having in these conditions. All these that you have got the infinite in the denominator, all these, they are simply zeros that we are having there. They are simply zeros that we have. So it's 18 minus 0 plus 0 minus what? Minus 0. That is the condition of our question. That is the condition of our question. The same thing that we are having here, 3 minus 0 plus 0 minus what? Minus 0. There's nothing that we're going to have. So it simply means we're going to left with what? 18 over what? 3. And 18 over 3, that will be what? That will be 6 at the end. So that is how these questions are given or might be given as. So you just need to work out as many questions as you can. So like I said, guys, as you can see, these classes going to take us a lot of time. So for us to support this, make sure that you become part of membership so that we don't miss any of the other classes that you're going to be having from this one that we have till we meet again.